We will present introduction, the overview of concrete Burj Khalifa. The Burj Khalifa is a symbol of the UAE progress and luxury as well as modern engineering achievement. It symbolizes Dubai ambition become a global business and tourism hub. The Burj, formerly announced as Burj Dubai, is the tallest man-made structure ever built in history. At 8 meters, construction began on September 21, 2404 until the exterior structure was complete on October 1, 2009 and officially opened on January 4, 2010. Next introduction, the type of concrete used for the building. The concrete used in the construction of Burj Khalifa is high strength concrete. Among the type and characteristic of concrete used in the Burj Khalifa building is high strength, which is the use of C40 to C80. Next, lightweight concrete is used to reduce the overall load of the structure and increase thermal efficiency. Finally, concrete with special additives which are divided in three, namely hardening additive, super plasticizer, water reducing additive, and early hardening additive.
Today I will continue our group presentation on first content, which is the detailed analysis of the material use of Burj Khalifa. So as we know, Burj Khalifa is an iconic skyscraper in Dubai, and Burj Khalifa is the tallest building in the world. The first material that used to construct Burj Khalifa is foundation. So Burj Khalifa structure is supported by large reinforced concrete, and the thickness of the mat is 3.7 meters and was constructed in 4 separate castings totaling 12,500 meters of concrete. And the piles used are 1.5 meters times to 43 meters on the diameter of the piles. Other than that, in order to minimize effect from corrosive chemicals in the underground water, construction of the Burj Khalifa has used concrete that has high density, low permeability, and a Catholic protection system under the mat. So we can see in the picture, which is it used many piles in the foundation of the Burj Khalifa. The second material used is podium. Podium is known as a pedestal or platform construction. Podium construction is a type building characterized by a horizontal division between a tower or a lower podium. In construction term, podium is recognized as a divide between the lower part and the upper part of the building. And the lower part is called as a podium. And it contains 1 or 2 floors and is built from a robust structural system such as steel or reinforced steel. Podium is usually have 1 or 2 floors that construct from a robust structural system such as steel or reinforced concrete. So in Burj Khalifa, podium provides a base and that anchors the tower to the ground and allows access from 3 different sides to 3 different levels of the building. So we can see in the picture, which is the podium has only from 1 until 4 or 5 levels, which is it has stated that 150 meter wide level. So the third material used is high strength steel, which is high strength steel is the most widely used level of structural steel with better bearing capacity, fire and heat resistance than ordinary steel. The advantages of using high strength steel is it is strong, durable and high strength structure. For example, that use high strength steel is the car frames, boat or factory structure and many more. So in construct the Burj Khalifa, they use the high strength steel to do the frame of Burj Khalifa because it is high strength of the steel itself. So this material also provides the rigidity and strength required for towering structures. So the fourth material used in Burj Khalifa, it is structural steel. Structural steel plays an important role in the framework because structural steel can provide strength and support to the entire structure. Structural steel is built in various forms, including beams, plates, and channel. So the advantages that can be obtained from the structural steel is the development of strength, sustainability, and many more. So this kind of steel, like high strength steel and structural steel, is important to construct the Burj Khalifa because Burj Khalifa is construction plan is a tall building that requires a high level of stability from the foundation of the building. So it is important from the foundation until the framework. It is so important for the construct the Burj Khalifa because Burj Khalifa is planning to do a highest or tallest building in the world. So if the framework of Burj Khalifa is not good, is not strong enough, it can make the building become collapse or falls if the wind go through the building. And the last material used is aluminium cladding. Aluminium cladding system is a durable building material used on the facade to protect the facility from the outside elements. In construction industry, cladding is the building covering system that protects the building by offering an additional layer while providing aesthetic. So, in Burj Khalifa, they use aluminum cladding also on the outside, which contributes to the aesthetic nature of the building, which looks elegant and modern. So they use the aluminum cladding to look that building is too good, too beautiful, too modern to attract the tourists to go to Dubai just for the Burj Khalifa. And other than that, Burj Khalifa is the tallest building in the world, so they need to construct the modern design at the outside of the buildings.
I would like to present about physical Burj Khalifa light density. The density of the concrete used in the Burj Khalifa was an important consideration. High performance concrete typically has a density of 2,400 until 2,500 kg. The use of thick concrete was required to assure the structure, strength and stability, particularly considering the building has high and gravitation stresses. A higher density concrete can support more weight, which is critical for the bottom floor of the tall structure. Next, porosity. The porosity of the concrete used in the Burj Khalifa need to be precisely regulated. High performance concrete often has reduced porosity, which is important for a variety of reasons. For reduced porosity, increased durability by limiting permeability, making it more resistant to water and other corrosive chemicals that might cause deterioration.
So now I would like to talk about mechanical properties on Burj Khalifa. As we know, the Tower of Burj Khalifa, situated in Dubai, is known as the tallest structure on the earth, which has been possible through the selection of right material and their mechanical properties. It has several notable mechanical properties that ensure its stability, strength, and functionality, which is comprehensive strength, tensile strength, and modulus elasticity. So, point number one is compressive strength. Number one is high strength concrete selection. For the Burj Khalifa, concrete with a compressive strength of at least 80 megapascal was chosen to ensure the building's stability under immense gravity loads, including its own weight, occupant, and furnishing. Number two is load-bearing capacity. The high compressive strength of the concrete is essential for supporting the massive loads transferred to the lower levels. The function is to preventing deformation or failure. And number three is structural stability. This property is crucial for maintaining the building's stability and integrity, ensuring it remains structurally sound despite its towering height. So next is tensile strength. In the context of the Burj Khalifa, tensile strength refers to the ability of the material used. This is crucial for the building's stability because it helps prevent structural failure and cracking due tension forces. Number one is concrete weak tensile strength. While concrete withstands high pressure, it is weak under tension, requiring reinforcement for improved tensile strength. Number two, steel reinforcement in Burj Khalifa. The building incorporates significant steel reinforcement with a tensile strength of up to 600 megapascals to handle and transmit tensile load effectively. Number three is wind and load resistant. The high tensile strength of the steel allows the structure to resist tensile stresses such as those from wind forces, preventing cracking and structural failure. It is the modulus of elasticity. In the context of the Burj Khalifa, the modulus of elasticity refers to the measure of material's ability to deform elastically when a load is applied. Number one is Young modulus and elastic deformation. Young modulus measures a material's ability to deform elastically under loads. It's to preventing deformation in the material used to construct Burj Khalifa. Number two is concrete's modulus of elasticity. The Burj Khalifa used stress concrete with a modulus of elasticity between 30 to 40 GPa, which means gigapascals, to maintain the building shapes under loads. And number three is steel reinforcement elasticity. The steel reinforcement in the structure has high modulus of elasticity, is ensuring rigidity and integrity, especially against dynamic forces like wind and natural disaster like earthquake.
Next is a durability factor, including resistant to environment challenges. The Burj Khalifa design has a wall-shaped floor plan and a tempering form which is limit wind pressure and the influence of water shedding, reducing oscillation. The external cladding was designed to endure Dubai action, including high temperature, UV radiation, and sand emission while requiring minimal maintenance. Next, a waterproofing measure, just as waterproof membranous and drainage system were used to keep groundwater from entering the basement and foundation. So finally, the Burj Khalifa endurance is a result of care, material selection, clever design, and rigorous building process that provide the temperature variation, corrosion, dampness, seismic activity, fire, UV radiation, and strong and performance in Dubai harsh environment.
I will talk about the production and construction process of Burj Khalifa, and next one, I will talk about the challenges during construction and how they overcome. The first one is concrete production and mixing. The Burj Khalifa construction used over 45,000 cubic meter of concrete for its foundation and total of 330,000 cubic meter of concrete along with the 39,000 tons of steel rebar. The rebar is laid end to end would exceed 25,000 of earth's circumference. The concrete mix, which include the additive Glenium Sky 504, allowed it to be pumped to head over 600 meters and remain workable for up to 3 hours. High performance Portland cement, crushed sand, gravel and chemical admixture were used to ensure the concrete strength, workability and durability. Next is spacing, which is pumping and placement. In November 2007, the Burj Khalifa set a record by pumping concrete to a height of 601 meters, surpassing previous record. The concrete was pumped using a high-pressure pulse-meter for 14,000 SHPD pump, moving at about 200 bars of pressure. It took 40 minutes for the concrete to travel from the hopper to the top, which is a piston stroke moving 26 tons of concrete. Over 32 months, this pump and two others delivered nearly 165,000 cubic meters of high-strength concrete. Next one is curing. In Dubai's extreme weather, the Burj Khalifa concrete needed careful curing to ensure strength and durability. Curing agents and water spray prevented rapid evaporation, while temperature control involved using ice, crushed stone and cold water. The concrete was kept wet 4 days to weeks with a blanket and shaded, protecting it from temperature change. Advanced sensor monitor temperature and moisture in real time, and concrete was poured in 3-meter layers to manage the heat of hydration. Regular testing ensured the concrete met the necessary strength and quality standard. The last one is construction techniques. The Burj Khalifa construction used innovative methods like self-climbing formwork system for efficient, continuous building of vertical components. High-strength reinforced steel ensures structural integrity with bar carefully positioned and secure. Embedded sensor allowed real-time monitoring of concrete temperature and strength, and regular testing ensure quality. These advanced techniques and ongoing monitoring enable the successful construction of the world's tallest building. There are a few challenges and the way they overcome it. First, pumping high-performance concrete. There were many difficulties in pumping high-performance concrete to height that were never before possible. However, a record pumping height of 601 meters was accomplished with the use of new mixture, altered procedure and strong pump like the Pulsemaster 14,000 SHPD. Next is logistical and safety issues. In order to address the logistical and safety issue associated with the pumping concrete at high elevation, samples were routinely examined in a site laboratory to assess the concrete state during pumping. Next is during curing and cracking. Proper curing prevents cracking in Dubai's humid climate. Technique like spray curing chemical and control permeability from liner improve the concrete strength and appearance. Additionally, the mild needle extreme temperature and use of crushed limestone aggregate reduce the need for formwork insulation to prevent thermal cracking. And lastly, mix design and quality control. Ensuring the performance and quality of the high-performance concrete mix was crucial. Proper mix design, placement, protection, and curing were vital to prevent issues like pump obstruction, circulation, shrinkage, and cracking.
So what is slump testing? Slump testing was a primary procedure used on concrete during the construction of the Burj Khalifa. This test assessed the workability and uniformity of newly mixed concrete before it sets. So the procedure of the slump testing. First, the fresh concrete is poured into the conical mold. The mold is then removed. The vertical distance that the concrete slump is measured. The purpose of slump testing. The test result provide insights into the concrete's fluidity. Understanding the concrete's fluidity is crucial for ensuring it can be properly poured and compact, especially on a large-scale project like the Burj Khalifa. The importance of the proper slump measurement. The first one is achieving the proper slump was critical for the Burj Khalifa. A low slump indicates stiff concrete, which is difficult to work with and may lead to inadequate compaction. A high slump suggests very moist concrete, which can weaken and deteriorate when hardened. Achieving balance in concrete mix. The project required a precise balance to ensure the concrete could be pumped to unprecedented height without compromising its qualities. Compressive strength testing. So what is the importance of that test? First thing first, a compressive strength is a crucial characteristic of the concrete. It indicates the concrete capacity to support weights without crumbling. Testing compressive strength. During the construction of the Burj Khalifa, concrete samples were frequently tested for the compressive strength. Concrete specimens are typically cast in molds, cured under the controlled condition, and then crushed in a compression testing machine at predetermined age. Necessity for high compressive strength. Ensuring the concrete had the necessary compressive strength was essential for the Burj Khalifa. The building's height and the weights had it bear required incredibly strong concrete. Consistency and reliability in testing. To guarantee consistency and reliability, engineers and material scientists likely conducted this test frequently and in various settings. Special tests due to unique project requirement. The first one is pumpability test. Pumping concrete to enormous heights was the one of the Burj Khalifa's special requirements. It's pumped to such height, regular concrete may separate or become unworkable. Pumpability tests were therefore necessary to guarantee that the uniformity and the quality of the concrete mix will not be compromised during transportation by pumps. Temperature control test. The weather in Dubai presented yet another formidable obstacle. Elevated temperature have the potential to quicken the concrete setting period, resulting in fracture and diminished durability. Tests specifically designed to regulate temperature were carried out in order to create a concrete mixture that would not crack under the intense heat. In order to regulate the temperature rise within the concrete throughout the curing process, this involved evaluating the impacts of various admixtures and curing techniques. Creep and shrinkage tests. The long-term deformation of concrete under sustained load and environmental changes brought on by moisture loss might have a substantial effect on the stability and appearance of the structure, the height of the Burj Khalifa. Therefore, in order to forecast these long-term behaviors and to design structural components and concrete mixture that will lessen their effects, creep and shrinkage studies were carried out. Durability tests. Durability testing was especially important because of the Burj Khalifa's planned lifespan and the challenging environmental conditions it would encounter. These tests evaluate the concrete's ability to withstand freeze, tow cycle, chloride penetration, and sulfate assault. These tests made sure that even when exposed to the potential harmful environment elements, the concrete would be able to retain its integrity and functionality for many years.
2.5. The architectural significance and specific use of concrete in the structure. The Burj Khalifa building is the one of the tallest building in the world and represents cutting-edge building design. From initial concept to completion, the combination of several key technological innovation and innovative structural design method has resulted in the efficient and robust superstructure. Structurally, Burj Khalifa is designed with a Y-shaped three-parted floor geometry. Burj Khalifa used a Y-shaped floor plan. This plan provides higher performance and provide a full view of the present goal. The shape and upward setback help the structure reduce the wind force acting on the structure. After conducting discussion, the shape was finally improved and changed based on a series of wind tunnel tests. The structural system used for Burj Khalifa can be called the buttress core system. Specific use of concrete in the structure, the Y-shaped plan is intended to form the core of the Burj Khalifa structure. In addition to its artistic and functional benefits, along with keeping the structure simple and enhanced constructability, this design reduced wind force on the tower. The structural system is known as an embankment core, which consists of high-performance concrete walls. Each wing supports a hexagonal hub or center core with 6 sides. Similar to a crossbar or axle, this central core provides torsional resistance to the structure. For example, SPY, the Burj Khalifa telescopic tower made of over 400 tons of structural steel, it is most striking feature. Hydraulic pumps are used to build the tower from within the building and swing it to a full height of more than 200 meters. Second is mechanical flooring. The equipment that power the Burj Khalifa is housed on 7 two-story mechanical floors, electrical substation, water tank and pump, air handling unit, and other components that are necessary for the tower's operation and the comfort of its residents are located on the mechanical floor, which is spread over the 30 floors.
Conclusion, the Burj Khalifa located in Dubai, United Arab Emirates is an incredible landmark and impressive feat of engineering. Burj Khalifa creates an engineering and architectural marvel whose iconic design inspired by the geometry of the Hemiocalist flower and Islamic culture results in a unique and aesthetic structure. There has also been criticism of the working condition and right of workers involved in its construction. Burj Khalifa brought a great impact of the economic tourism image of the city despite facing various challenges in its construction.